Shoaling and schooling. In biology, any group of fish that stay together for social reasons are shoaling, and if the group is swimming in the same direction in a coordinated manner, they are schooling. In common usage, the terms are sometimes used rather loosely. About 1/4 of fish species shoal all their lives, and about 1/2 shoal for part of their lives. Fish derive many benefits from shoaling behavior, including defense against predators, through better predator detection and by diluting the chance of individual capture, enhanced foraging success, and higher success in finding a mate. It is also likely that fish benefit from shoal membership through increased hydrodynamic efficiency. Fish use many traits to choose shoal mates. Generally, they prefer larger shoals, shoalmates of their own species, shoalmates similar in size and appearance to themselves, healthy fish, and kin when recognized. The oddity effect posits that any shoal member that stands out in appearance will be preferentially targeted by predators. This may explain why fish prefer to shoal with individuals that resemble themselves. The oddity effect thus tends to homogenize shoals. An aggregation of fish is the general term for any collection of fish that have gathered together in some locality. Fish aggregations can be structured or unstructured. An unstructured aggregation might be a group of mixed species and sizes that have gathered randomly near some local resource, such as food or nesting sites. If, in addition, the aggregation comes together in an interactive, social way, they may be said to be shoaling. Although shoaling fish can relate to each other in a loose way, with each fish swimming and foraging somewhat independently, they are nonetheless aware of the other members of the shoal group, as shown by the way they adjust behavior, such as swimming, so as to remain close to the other fish in the group. Shoaling groups can include fish of disparate sizes and can include mixed species subgroups. If the shoal becomes more tightly organized, with the fish synchronizing their swimming, so they all move at the same speed and in the same direction, then the fish may be said to be schooling. Schooling fish are usually of the same species and same age or size. Fish schools move with the individual members precisely spaced from each other. The schools undertake complicated maneuvers, as though the schools have minds of their own. The intricacies of schooling are far from fully understood, especially the swimming and feeding energetics. Many hypotheses to explain the function of schooling have been suggested, such as better orientation, synchronized hunting, predator confusion, and reduced risk of being found. Schooling also has disadvantages, such as excretion buildup in the breathing media and oxygen and food depletion. The way the fish array in the school probably gives energy-saving advantages, though this is controversial. Fish can be obligate or facultative shoalers. Obligate shoalers, such as tunas, herrings, and anchovy, spend all of their time shoaling or schooling, and become agitated if separated from the group. Facultative shoalers, such as the Atlantic cod, saithes, and some carangids, shoal only some of the time, perhaps for reproductive purposes. Shoaling fish can shift into a disciplined and coordinated school, then shift back to an amorphous shoal within seconds. Such shifts are triggered by changes of activity from feeding, resting, traveling, or avoiding predators. When schooling fish stop to feed, they break ranks and become shoals. Shoals are more vulnerable to predator attack. The shape a shoal or school takes depends on the type of fish and what the fish are doing. Schools that are traveling can form long, thin lines, or squares, or ovals, or amoeboid shapes. Fast-moving schools usually form a wedge shape, while shoals that are feeding tends to become circular. Forage fish are small fish which are preyed on by larger predators for food. Predators include other larger fish, seabirds, and marine mammals. Typical ocean forage fish are small, filter-feeding fish such as herring, anchovies, and menhaden. Forage fish compensate for their small size by forming schools. Some swim in synchronized grids with their mouths open, so they can efficiently filter feed on plankton. These schools can become huge, moving along coastlines and migrating across open oceans. The shoals are concentrated food resources for the great marine predators. These sometimes immense gatherings fuel the ocean food web. Most forage fish are pelagic fish, which means they form their schools in open water and not on or near the bottom, demersal fish. Forage fish are short-lived and go mostly unnoticed by humans. The predators are keenly focused on the shoals, acutely aware of their numbers and whereabouts, and make migration themselves, often in schools of their own, that can span thousands of miles to connect with or stay connected with them. Herring are among the more spectacular schooling fish. They aggregate together in huge numbers. The larger schools are often formed during migrations by merging with smaller schools. Chains of schools 100 kilometers, 60 miles, long have been observed of mullet migrating in the Caspian Sea. Radakov estimated herring schools in the North Atlantic can occupy up to 4.8 cubic kilometers, 1¼ cubic miles, with fish densities between 0.5 and 1 fish per cubic meter, totaling about 3 billion fish in a single school. These schools move along coastlines and traverse the open seas. Herring schools in general have very precise arrangements which allow the schools to maintain relatively constant cruising speeds. Herrings have excellent hearing, and their schools react very rapidly to a predator. The herrings keep a distance from a moving scuba diver or a cruising predator like a killer whale, forming a vacuole that looks like a donut from a spotter plane. Many species of large predatory fish also school, including many highly migratory fish, such as tuna and some ocean-going sharks. Cetaceans, such as dolphins, porpoises, and whales, operate in organized social groups called pods. Shoaling behavior is generally described as a trade-off between the anti-predator benefits of living in groups and the cost of increased foraging competition. Landa, 1998, argues that the cumulative advantages of shoaling, as elaborated below, are strong selective inducements for fish to join shoals. Parrish, et al., 2002, argues similarly that schooling is a classic example of emergence, where there are properties that are possessed by the school but not by the individual fish. Emergent properties give an evolutionary advantage to members of the school which non-members do not receive. Social interaction. Support for the social and genetic functions of aggregations, especially those formed by fish, can be seen in several aspects of their behavior. For instance, experiments have shown that individual fish removed from a school will have a higher respiratory rate than those found in the school. This effect has been attributed to stress, and the effect of being with conspicuous therefore appears to be a common one and a powerful social motivation for remaining in an aggregation. Herring, for instance, will become very agitated if they are isolated from conspecifics. Because of their adaptation to schooling behavior, they are rarely displayed in aquaria. Even with the best facilities aquaria can offer, they become fragile and sluggish compared to their quivering energy in wild schools. In It has also been proposed that swimming in groups enhances foraging success. Foraging advantages. It has also been proposed that swimming in groups enhances foraging success. This ability was demonstrated by Pitcher and others in their study of foraging behavior in shoaling cyprinids. In this study, the time it took for groups of minnows and goldfish to find a patch of food was quantified. The number of fishes in the groups was varied, and a statistically significant decrease in the amount of time necessary for larger groups to find food was established. Further support for an enhanced foraging capability of schools is seen in the structure of schools of predatory fish. Partridge and others analyzed the school structure of Atlantic bluefin tuna from aerial photographs and found that the school assumed a parabolic shape, a fact that was suggestive of cooperative hunting in the species. The reason for this is the presence of many eyes searching for the food. Fish in shoals share information by monitoring each other's behavior closely. Feeding behavior in one fish quickly stimulates food-searching behavior in others. Fertile feeding grounds for forage fish are provided by ocean upwellings. Oceanic gyres are large-scale ocean currents caused by the Coriolis effect. Wind-driven surface currents interact with these gyres and the underwater topography, such as seamounts, fishing banks, and the edge of continental shelves, to produce downwellings and upwellings. These can transport nutrients which plankton thrive on. The result can be rich feeding grounds attractive to the plankton-feeding forage fish. In turn, the forage fish themselves become a feeding ground for larger predator fish. Most upwellings are coastal, and many of them support some of the most productive fisheries in the world. Regions of notable upwelling include coastal Peru, Chile, Arabian Sea, western South Africa, eastern New Zealand, and the California coast. Copepods, the primary zooplankton, are a major item on the forage fish menu. They are a group of small crustaceans found in the ocean and freshwater habitats. Copepods are typically 1 mm to 2 mm long, with a teardrop-shaped body. Some scientists say they form the largest animal biomass on the planet. Copepods are very alert and evasive. They have large antennae. When they spread their antennae, they can sense a pressure wave from an approaching fish and jump with great speed over a few centimeters. If copepod concentrations reach high levels, schooling herrings adopt a method called ram feeding. Herring ram feed in a school of copepods. They swim with their mouth wide open and their opercula fully expanded. The fish swim in a grid where the distance between them is the same as the jump length of their prey. Juvenile herrings hunt the copepods in a very synchronized way. The copepods sense with their antenna the pressure wave of an approaching herring and react with a fast escape jump. The length of the jump is fairly constant. The fish align themselves in a grid with this characteristic jump length. A copepod can dart about 80 times before it tires. After a jump, it takes it 60 milliseconds to spread its antenna again, and this time delay becomes its undoing, as the almost endless stream of herrings allows a herring to eventually snap the copepod. A juvenile herring could never catch a large copepod. Reproductive advantages. A third proposed benefit of fish groups is that they serve a reproductive function. They provide increased access to potential mates, since finding a mate in a shoal does not take much energy. And for migrating fish that navigate long distances to spawn, it is likely that the navigation of the shoal, with an input from all the shoal members, will be better than that taken by an individual fish. Forage fish often make great migrations between their spawning, feeding, and nurserying grounds. Schools of a particular stock usually travel in a triangle between these grounds. For example, one stock of herrings have their spawning ground in southern Norway, their feeding ground in Iceland, and their nursery ground in northern Norway. Wide triangular journeys such as these may be important because forage fish, when feeding, cannot distinguish their own offspring. Capelin are a forage fish of a smelt family found in the Atlantic and Arctic Oceans. In summer, they graze on dense swarms of plankton at the edge of the ice shelf. Larger capelin also eat krill and other crustaceans. The capelin move inshore in large schools to spawn and migrate in spring and summer to feed in plankton-rich areas between Iceland, Greenland, and Jan Mayen. The migration is affected by ocean currents. Around Iceland, maturing capelin make large northward feeding migrations in spring and summer. Their return migrations take place in September to November. The spawning migration starts north of Iceland in December or January.